Okay, class, today we're going to look at transformations part 2. So we're going to explore horizontal transformation, and if you recall, we already explored vertical transformations. So when I look at my graph of y equals f of x, I have to figure out what each of my values are. So I know that right here I have a negative 4, and if I go up to look at this value, I know that coordinate is negative 4, 3. So I'm going to have to do the same for each one of my coordinates. So that's why they're giving you the table here. If I have f a negative 4, I want to know what the actual value of y is. So go ahead and fill out the table. If you want to do it on your own, then pause your video now because I'm about to show you the answers. So now I have my y values. So now that I have my y values, I need to see what transformation needs to take place. So when I look here, I see they want me to take x and add 2 to it. But you got to remember that in your formula, what your formula really says is x minus a negative 2. That's what it really says because there's a negative in the formula. Remember we talked about your h always doing opposite of what you wanted to? So I know my value is a negative 4. So what I'm really doing to that negative 4 is I'm subtracting 2 from it. So because I'm subtracting 2 from it, I'm going to get a value of negative 6. Make sure you understand that. So if I have negative 4 and I'm going to take 2 away from that, I'm going to end up with a negative 6. So what do you think that you'll get on the next one? If I were to take a negative 3 and apply a negative 2, in turn I'm going to get what? That's correct, a negative 5. So now we're going to see how they plot the next points. So it's important to note here that what happened is the whole function had a horizontal translation by a negative 2. So you usually think when you see a positive 2, it's going to move to the right. This is always going to do opposite of what you think because there is a negative in the equation. So it's really moving to the left, negative 2. Make sure you get that. If not, you're going to need to rewatch this part of the video. Let's keep going. So now, if I look at x minus 2, I should already be able to hypothesize that now this is going to move to the right 2 because I said opposite of what you think. So if I see x minus 2, my first thought is that's going to move to the left 2. But because I know there's a minus in the equation, this really says x minus, and the value I plugged in was a 2. So this means I'm going to go to my right 2. So I'm going to take each of my coordinates and I'm going to move them over right 2. And then I'm going to draw my graph. But now remember, I always got to verbalize what happened. So what happened here? I know I had a translation. And I know that because this is inside with my x, it was a horizontal translation. So what I have to write is that the function has a horizontal translation by 2. Okay, let's keep going. So now I have another value inside my x. So I'm going to use this as a time to stop and clarify something that may help you a little more. If I have the equation y equals a bx minus c plus d. Take a moment, make sure you're really looking at this. I recognize that my d is on the outside with my y. I also recognize that the a is on the outside with the y. So anything that's done to my d and my a is going to have a vertical effect. Well, I also recognize that my c is on the inside with my x, and my b is also on the inside with my x. So whenever anything is done with my b and c, it's going to have a horizontal effect. So make sure you understand that. If I'm in here with my x, I'm going to have a horizontal effect. Why am I having a horizontal effect? Because X is horizontal. If I'm outside with my Y, I'm having a vertical effect. Why am I having a vertical effect? Because my Y is vertical. I hope that really helps y'all. So let's keep going. So when I look at this 2 on the inside, I know it's going to have what kind of effect? That is correct, a horizontal effect. Now, what did we talk about a second ago when I said that Y equals X minus H plus K? I know I'm using a different term, but I still want you to recognize that no matter what variable I put there, this is still inside with the X, this is still outside with the Y. Excuse me. So I said that because this is negative, your horizontal effects inside here is always opposite of what you think. When I think that -2 is going to go to the left, what did it do? Correct, it went to the right. When I thought that +3 was going to go to the right, what did it do? It went to the left. So based upon that, what do we think is going to happen when we look at the 2 on the inside? What do you think is going to happen there? Okay, so you would think looking at it that I was going to have a horizontal dilation by 2. Let's take a look at what actually happens. Look at this point. Okay, let's take another look at the next point. Look at that point. I'm going to go ahead and plot the point so you can see what actually happens. Okay, so we said we thought I was going to have a horizontal dilation by 2. But instead, what did it do? This point was -4. It became -2. So it cut it in half. Do you see that it cut each of these points in half? So what you should see that instead of this having a dilation by 2, it had a dilation by half. So let's talk about what we said about it always being opposite of what you think. So I'm thinking because that's 2 over 1 times X, it's going to have a dilation by 2 over 1. But because it's inside the parentheses, it's going to do opposite of what you think. So it's going to have the reciprocal effect on it. So it's going to actually dilate by 1/2. And this is the only place where on this video is going to be wrong because they put a 2 here. But you'll see that they correct it later on. So make sure you understand that this is by a 1/2. So let's look at the next one. So what do we think it's going to do? Okay, Ms. Tad, you said that when it's inside with the X, it's going to have a horizontal effect. And I know that what's inside with the X is a 1/2. So I can deduct that it's probably going to have a 2 over 1 dilation. So let's take a look and see if that's actually what happens. Okay, so here we go. I'm plotting my points. And you see it's correct. It does have a horizontal dilation by a factor of 2. Okay, let's keep going. So now I'm dealing with a negative inside. So what effects do you think is going to occur if I have a negative inside? Remember, I got to take whatever my X value is and make it negative. So let's talk about what that looks like on my graph. So I know I have a -4, -3, -2, -1, so on and so forth. But I'm going to multiply it by a negative. So that's simply going to change all my values to a positive value, right? A negative times a -4 is going to give me a +4, so on and so forth. So now that I have a 4, now I got to place that value inside of my function. So let's take a look at what happens. So that's going to give me a 3. That's going to give me a 0. And then so on and so forth. So when I look at what it did, I can actually see that it did what? That's right, it reflected. What did it reflect across? Because it is my x, and I have my y, inside is always going to give me a reflection across the y. Whatever's over here is going to end up over here. It reflects across the y. So make sure you note that when that is negative, it reflects across the y. Okay, I hope that is crystal clear to you, because some of you are probably sitting there thinking, wait, Miss Head, I thought it was going to reflect across something else. So let's talk about why it's across the y. If I'm going to reflect horizontally, and this is my shape, if I reflect horizontally, whatever is over here is going to have to end up over here, correct? So when I look at that, I know this piece here is going to have to go over here. And I know this piece here is going to have to go over here. So make sure you understand that. Okay, let's keep going. So now we're doing something really different. Now I'm taking the absolute value of my x inside the function. So let's talk about what that looks like. So once again, I have my values, and I know that my absolute value only measures my distance from 0. So my negative becomes positive, but my 1 stays positive. Because when I'm looking at absolute value, I'm trying to figure out how far it is from 0. So if I'm over here at -4 and I'm over here at 4, how many units is this -4 from 0? It's 4 units. How many units from this 4? How many units is this 4 from 0? It's also 4. So remember, it measures distance, so that's why this becomes a +4. Just wanted to make sure y'all understand the whys. So now that I have the absolute value, now I want to actually use my function and plot my points. So when I do, these are the points I'm going to get. I'm going to get a -2, a 0, a 2, and so forth. And I'm going to plot these coordinates. Hopefully you're plotting yours on your graph as well. So what do you notice happened? You should notice that all the positive x values reflected horizontally across the y value. So all the positive parts over here reflected across the other side. Remember, if you need more time, you can always go back. So now I'm doing two things. So hopefully by now you remember enough to know that this is on the outside, so that's going to have a vertical transformation. So it's going to go up 1. This is on the inside, so it is going to have a dilation by a factor of, wait, it's on the inside, it's opposite of what I think, so it's going to be half. But it's also negative, so it's going to reflect across one of the axes. So let's actually look at it. Reflect across the y-axis is my negative. Dilation by a factor of half, which is always half of the width. And then translate up 1 unit. Good job. And then we can graph that. And it's showing how we would actually write that out. Let me move that to make sure you can see it. So hopefully you understood that. If you have any problems, make sure to just pause your video or go back and watch your video and make sure you write down any questions you have for me. Have a good evening.